Hi, welcome to ClapLab. My name is Marco Martinez. At the last minute, I decided to participate in the AWS Marketplace Challenge. The challenge consisted of using one of the SageMaker Marketplace um, machine learning models that were available to use. And basically, like 3 days ago, I had an idea and I decided to participate again at the last minute. So let me just show you what's the product or the final product that I was able to create in the last couple of days. This is the portal. Right now it's running on my local computer, locally on my computer. So let me sign in. Let me refresh the site. Okay. So I'm gonna load one image of with people, and I'm gonna explain you what this application does. So I'm gonna load this people that JPEG file. You will see that it's uploading the file to the cloud. Okay, it's done uploading, and it also automatically downloaded the result of the machine learning model. So as you can see, what's the purpose of this application? It's to basically measure the safe distance for the COVID-19 pandemic that we are currently living everyone around the world. So what this application does is basically detect, based on your parameters, detect which people are too close from each other. So for example here, this couple, it's 55 pixels from each other. So we have a threshold. And again, the idea here was to use basically real world measurements, but due to time constraints, I was not able to achieve that. So once again, with the limited time that I had, we have this result. So basically here, this is the distance from, so right now, for example, here, let's set this up to 61 pixels across. So anything that was detected that it's close to each other, that is 61 pixels closer to each other, will be reported on this image. So for example, here we have 8 infractions. So 8 different, we detected 8 different people that were closer than 61 pixels across. 1, 2, 3, 4, 5, 6, 7, 8, and let me just zoom out, and yes, we have 2 here, 3, 4, 5, 6, 7, 8 people or 8 couples that were detected. So what are the options that we have here? So first we have here the option to choose a file. We only this application only supports JPEG files. So let me just load another image. Okay, don't upload it, uploading, getting the machine learning object, and done. Okay, we have, so it didn't detect anything, so that's probably because they are too close. So let's increase the distance. Yeah, so they are here a 93, this person from the live, it's 93 pixels from the person from the center, and the person from the center, it's 106 pixels from the right. So we have different settings that we can change. For example, the color of the text, we can change the line color, the width of the line, if we want to change the fill color of the square. So we have a lot of options. And down here we have for example, here, this machine learning model, the result is a JSON object with an array of results. So for example, here we detected people, and here I set that, okay, anything that is lower than 60% result won't be, so the accuracy of the machine learning results. So for example here, let me just increase that, okay, right here. So you see that this person disappeared. It means that that person, the machine learning model wasn't, the result for this person was lower than 92%. It's probably close to 90. Yeah, 87%. So the machine learning model detected that this is a person, but only to an 87% confidence, and the rest was higher. So we have that parameter that we can change. So let's load another image. So what's going on the background? Let me also explain that. Let me upload this image that's a little bit larger. Again, it's right now we choose a file. The file's been uploaded to S3. Once the file is uploaded, we have a Lambda function that is automatically starting an event. Yes, it's an event trigger it's starting, or let me just get the name right. The SageMaker endpoint, and SageMaker endpoint to detect the objects on the scene. So if I go back here, so once that is completed, we are also downloading that JSON result in order to get the position of the objects, the score of that object. Then I run a small calculation to detect the distance between people. And let me just have here. Yeah. So here we have the result. Again, let's increase the distance. Yep. So this is it basically. So let me just show you again how this project works more or less. As you can see, we have a logout button. So what it means is that we are using AWS Amplify service to basically have a login function, or actually a login screen. So we have an identity manager that's powering our application. So only people that are logging into our service will be able to do those actions on our backend service. So for example, only a person that's logging will be able to upload files to S3 and also download files from our S3 bucket in order to get the JSON file. So let me just show you the backend. Again, the backend is primarily made of, this is the event trigger of the S3 put file. So this function, again, it's getting triggered when we are uploading the image, the JPEG image. So this is, by the way, this is the S3 bucket. So these are the files that we uploaded, and also the JSON file that's getting created once the machine learning model processes and detects the objects on the scene. So again, very simple stuff. We're just first we're getting the object from the S3 bucket. Then we're triggering an SageMaker runtime function to basically detect the objects on our scene. Then once we have that result, we're creating a JSON file in our S3 bucket. So those are the 3 steps that we are completing in one shot. And again, this is the S3 bucket. So once again, first we're uploading an image. That image is triggering a Lambda function. That Lambda function first gets the object from S3, sends that object or that binary data to SageMaker. SageMaker returns a JSON object, JSON file, raw data, and also a blob. And then we are storing that result in S3 again. So it's sending that to SageMaker, then storing that result on S3. And by the way, this is SageMaker, again, the endpoint that we are using. And this is the ML model, machine learning model that I use for this challenge, is the MXNet YOLO V3 object detector. Again, this one is free, so that's one of the reasons why I choose this model. Again, was to make things free. And I also want to thank Amazon for actually they gift $100 credit during this challenge, so I didn't have to spend any of my money for this challenge. Again, you can know more about the challenge and from the Devpost original blog post. This is the URL that you will have access. Again, I hope that you like it. One of the ideas that I wanted to implement, but due to time constraints, I didn't have time to implement, was to basically have a drop-down menu with different drones, like for example the Mavic Pro, the DJI Spark, the DJI Phantom, all those drones. And with that information, and knowing exactly which camera they have and focal length, basically just have that as a parameter and use the focal length plus known distance, and basically instead of having here, for example, the distance in pixels, have the distance on centimeters or feet or inches to have more a more accurate response. But again, nothing wrong with what we did. Again, we based on the results that we have, we can basically still use it. It's usable, but again, it will be much easier to interpret that data if we have real data. Like for example, here, if we know exactly that this image is I don't know, let's say 5 meters the objects are 5 meters from the camera, and we know the camera length, we can more or less calculate the distance from each person instead of having pixels. So I hope that you like the project. Again, I forgot to show you. Okay, the front end, the portion that you're watching here on the screen, it's was made on React.js plus different libraries. Let me just show you the JSON package. So we're using Canva for drawing in the canvas. So we are drawing squares, numbers, lines on the canvas. What else? Axios for getting the JSON result. This is for what else that's interesting. Okay, obviously amplifying. That's the library that's basically doing the security part, and it's enveloping the entire app with that security part, and that's allowing us to push our image to S3 and also to retrieve a temporary URL that we can later use in Axios to pull down the JSON result. So again, I won't show you much here, but again, it's again, I didn't have much time to work on this project, but again, very simple. You will have access to the entire source data, the portal, again made on React plus Amplify plus Material UI plus Axios plus different frameworks and libraries that were used. I'm sorry, and the backend that was made on Node.js. Hope that you like the project. Have a nice day. Bye bye.